I'm going to go ahead and share my screen to start a walkthrough. I'm going to take probably about 45 to 50 minutes to try to leave us some time for Q&A at the end. As several mentioned, everything I'm about to show you is in our SaaS product, TileDB Cloud, the hosted version that we have at cloud.tiledb.com. So anyone can sign up and follow along with what I'm doing. Also, the demonstrations that I'll show will be made available with direct links after the webinar, so you can follow along afterwards also. But it's important to note that every single feature I'm about to show you is available for on-premise use also. So there's nothing special about the SaaS product. We're not locked into anything on Amazon or Azure or anything like that. Everything can be deployed and usable from your own clusters. In addition to that, everything that I'm showing you today, of course, is going to be mostly through the web interface. But as Stavros mentioned, we have REST APIs available for everything. So not just the direct data access, but even the listing page that I'm on here for data management is available via programmatic APIs. So it's very easy to work TileDB Cloud into any type of environment you have directly from the website, or if you have a requirement to hit some of the APIs programmatically, perhaps maybe some of the audit or login APIs, all of that is available to you. To get started with, I'm going to give you a brief overview of the data management, some of the data management features that we have in TileDB Cloud. Then I'm going to move into some of our sharing and collaboration with the notebooks, and then some of the actual computations that we offer in the system here. Finally, as several mentioned, I will highlight a little bit around the dashboards and a sneak peek at our machine learning models and some of the details around that. So in TileDB Cloud, what we're viewing right now is the arrays that are owned by myself or the TileDB organization that I'm a part of. And right off the bat, we can see that TileDB has a very large and diverse data set. So when we talk about it being universal and storing different types of data, we truly mean it, and you can see it right here. We have some VCF data from the 1,000 Genomes Project. It's about 70 gigs in size. We have a LiDAR data set from Boulder, Colorado, a little less than a gig in size. We have some taxi data from the New York City taxi data set that a lot of you might be familiar with from the SQL world, very popular there. We'll actually talk a little bit about the taxi data in some of our demos later. And then, of course, we also have some additional LiDAR from the New Jersey data that comes in at about 51 gigs. So you can see we're all across different domains with a lot of different data types available in the system. And it's very easy to not only see the arrays that belong to you, but I can also flip over and see anything that's been shared with me directly. So one of our partners, ExactEarth, has shared a couple of different arrays, so I can see some of that data. I can see some data that Stavros has shared with me and some other employees. It's very easy to come in here and look for that. We also have, as you would imagine in any type of data management platform, very easy to search by keywords, by category, hashtags, all of that functionality is available. We have advanced filtering capabilities. So, by and large, everything you expect from a modern website we support, and this really will help you with your data management. As your data grows and the number of arrays grow, we make it very easy to group the arrays, catalog them, and work them through the system. So let's look at one particular array real quick to touch on some of the individual features that are here. I'm going to highlight just a couple items, and we'll leave some things for later on in the webinar. But the first thing I want to show right off the bat is we provide a lot of data management aspects directly for you as the user. Some of it programmatic, some of it human readable. So for instance, you can see we have a very nice markdown description that you can have in the system. This is full markdown. Think like GitHub README style. You can have images, tables, embed whatever you'd like, links through the system here. Very easy to do. We also have, the high level details of the array. The size, what type, what permissions do you have? In this case, I'm the administrator of this array, so I have a little bit extra information compared to a read-only user. If one of you log in, look at this data from the public perspective, you're going to see a little bit less information. And that's because everything in TileDB Cloud revolves around role-based access controls, and we take access very seriously. So every little detail we coordinate with should it be made available to users of different permission levels. Now, in this case, because I'm an admin, this allows me to see some additional information, such as the actual S3 location. So this array is stored on S3 in a particular bucket. Now, as an end user, we abstract that away. You would only ever use the TileDB URI that we provide over here. So if you want to access the array, you use the TileDB URI. But of course, as an administrator, you're going to want to know like what's the actual bucket, where is it stored, and so we provide that information to you. And it's also important to note that in this case, it's stored on S3, but this just as easily could be an Azure Blob Store, Google Cloud Storage. For enterprise users, this could be a shared file system like LusterFS or NFS mounts. A lot of flexibility where the data is actually stored in the system. And of course, we have the category hashtags, as I mentioned. We also provide the array schema available at a very high level for a quick overview. So you can, see what are the filters, or what are the compression used, what are the dimensions and the attributes and all the different date times available in the system. For those that are not quite familiar with arrays, you can think of this like a show create table in a traditional SQL database. It provides all the details you would need to figure out how to query the data itself. Now, in addition to the schema, we also show the array metadata. So TileDB arrays allow you to attach arbitrary key value metadata to the array itself. This is very powerful. So you don't actually have to store that metadata somewhere else. A lot of times people use Excel spreadsheets or another SQL database to try to store this arbitrary metadata that's associated with the data set. TileDB lets you store it directly on the array. And then, of course, in the UI here, we render it live for you. You can have strings, date times, integer values. Anything could be supported for the keys and the values here. So a lot of flexibility is offered in the system. Now we have a couple other items around pricing, sharing, and the activity logs, but I'm going to leave those for a deep dive in just a few minutes of the UI. The important thing that I want to highlight next, though, is that everything in TileDB Cloud is actually stored as an array. So the basic functionality that I've just showed you is available for everything: notebooks, user-defined functions, dashboards, and even the machine learning models. So if we take a look at a notebook, for instance, we'll just open up with a quick start serverless one. You're going to notice all of the same functionality exists. You'll have the description, a full markdown description that's available, the permissions, licensing of the data, or the notebook in this case, your category hashtags. You have the same tabs around sharing, activity, settings. But there are a few differences that we have when it comes to the notebooks, UDFs, and dashboards, because again, they are a little bit more than just data themselves. So for notebooks, we actually have a very nice preview functionality available in the system. So this lets you link this notebook out to users, make it available to the public at large. Anyone can then come, or a coworker of yours can come, take a look at the notebook. They can view it rendered here very nicely. Output is rendered. And if they decide that they're interested in this notebook, you can simply click the launch button. And if you click launch, this is going to take you into a dedicated environment where this notebook will actually works. We'll do that in just half a second here to show the functionality. But we also have the download button here, and I just want to highlight. So everything in TileDB Cloud is owned by you, the user. So this data is actually stored in an S3 bucket, and we'll talk a little bit about how that storage actually works in just a second, but it's stored in your own S3 bucket where you have full access. But we also make it very easy for you to download this notebook directly to your laptop if you want to modify it locally, and then you can always re-upload it live. A lot of flexibility in what we offer here. So if you decide you want to actually launch this notebook, you can simply click the launch button. And what actually happens right now is we are spinning up a dedicated environment just for you for the Jupyter Lab instance. The notebook settings and parameters are pre-configured for this notebook. So when a notebook is created, we record the environment that is there, what image type, what server sizes are used. We'll talk a little bit about how that actually works in just a second. And then so when the user comes back, wants to launch it, everything's pre-configured. You don't have to worry about which environment do you need. Is this a geospatial notebook? Is this a basic one? Is it genomics? Everything will be taken care of for you. So it makes it very easy to share and collaborate with the notebooks here in the environment. So when you launch directly into Jupyter Lab, you are presented with a Jupyter Lab environment that is going to be very familiar to anyone that's used this in the open source world. We pretty much run the open source Jupyter Lab with a few extensions added to it. So we have an extension, of course, to actually store the notebooks as TileDB arrays. So we have a content plugin that we've built that lets you actually store this TileDB this notebook as a TileDB array, backed by an S3 bucket in the TileDB format. So you get all the functionality inherited by TileDB. You get time traveling support. So you can actually go back in time, see what the notebook was like a week ago. And with our multi-reader, multi-writer, that means you have a collaborative environment. So I could be in this notebook running it, and at the same time, Stavros could also be making modifications, but we won't step on each other's toes because TileDB natively supports handling the multi-reader environments here. Also, in the Jupyter Lab environment that we have hosted here, you do get 2 gigs of persistent storage space as a scratch space, so to speak, if you want to maybe render an output image or develop some things for testing. But we do make it very simple and easy for you to create the notebook itself as a TileDB Cloud notebook. So you can simply go to New Launcher, and we have a notebook item here for TileDB Notebook. Click Notebook. It opens up a little dialog, and you can pick all the options. What should the notebook be called? What's the S3 path? Of course, we let you set defaults for all of these. So I have a default S3 path here, and your credentials that you could set. And the owner, of course, much like GitHub and GitLab and other systems, TileDB has organizations, and we let you, when you create assets, pick who owns it, right? Do I own it? Does my organization own it? And go from there. And this makes it very simple and easy. You can also pick the kernel. So of course we have Python notebooks, but we also have Bash, R, Julia, and other environments coming up soon. I'm going to create this as a Python notebook. So when I create this, what's actually happening is the basic notebook is created in Jupyter Lab just like normal, but the actual backing is going to be this S3 path, and it's registered and created in TileDB Cloud, where you're going to get all the functionality envisioned in the TileDB Cloud. So if I just, as a quick example, just print out hello, and I run that, and then if I save it, we're actually able to go over to the Notebooks tab once the saving's finished here, and we can see my example notebook, and you'll have all the information available to you live. You can see the details. I could add the description, the licensing, all that type of information, but you see the image is created, the server profile is automatically selected, and of course the preview with that single command and the output is available right there. So this makes it very, very simple and easy for you to create notebooks live in the environment to work and collaborate with your coworkers. So once you have the data in TileDB, of course you want to explore, and we make it very easy for you to come in and do that. Now, when I launched directly into the notebook, we skipped over the actual launching steps. So let me show you exactly how that works. If I shut down my notebook here, will take me back to the launch screen. And in TileDB Cloud, we have a few pre-configured environments for you with a variety of packages that are most commonly used by people, data science in the different domains, whether it's geospatial, whether it's genomics, and then of course a few different server profiles for you to pick from. So if we give it a second here, it'll take me back to the launch screen. And so when you select your image, again, like I say, we have 3 different ones pre-configured in our SaaS environment. But of course, enterprise users are able to customize this. You can have custom images. We, of course, are always listening for feedback on the installed packages and the variety that's available here. But we have a basic one for data science, one for genomics, one for geospatial with different server profiles. A small one, which mimics kind of more or less a laptop with available resources, works really well with our serverless computations, which we'll highlight in just a moment. And also a large one, if you're trying to run something local in your notebook, you're doing a little experimentation, you want to test locally, we do provide that large resource. One thing I want to note too is coming up very shortly here, we're also going to have the ability to have GPUs attached to notebooks. So as we talk about machine learning in just a moment, we're building out the GPU functionality to accelerate all of that. So when you have your notebook environments, like I mentioned, very easy to collaborate, but how do you actually collaborate with that? Let's take a look at the New York City taxi data once again, but I want to highlight the sharing capabilities this time that are built into TileDB Cloud. So we have this sharing tab that makes it very easy for anyone to come in the system and share. So I simply click share with. I could type someone such as Stavros. I give him permissions. I can say read only. I click share, and he instantly gets access to this array with whatever permissions I've given him. As the owner of the data, I did not have to manage IAM roles. I did not have to manage S3 bucket policies. I had to simply just select him from the list and send them an invite. Of course, you can also invite by email address or organizations as a whole. So this makes it super, super easy and powerful to collaborate and share with anybody in the system without managing the underlying file system access. I think we all know how difficult S3 bucket policies are. It seems like once a month, some bank makes a mistake and releases a bunch of our credit card information through S3 policies. So we wanted to have TileDB make it super easy to share and collaborate. We have our own access control system that we've built into the system that facilitates all of this. So what actually happens here when the data is shared? If Stavros now came in to access this array, what actually happens is he talks to TileDB Cloud. for all of his querying, whether it's Python slicing, whether it's serverless SQL, whether it's running from Spark or Dask. It doesn't matter how you interface with it. He'll talk directly to TileDB Cloud. TileDB Cloud then, on his behalf, will securely access the underlying data that's stored, whether it's on S3, Azure, or some other file system. Stavros would never actually get direct access to the data. TileDB Cloud facilitates everything, and all of it goes through the TileDB Cloud system here. And if you want to revoke access, whether it's to a user, organization, or whatnot, simply click the revoke button, and Stavros instantly loses access to the data. So this makes it super simple and easy to keep a list of who's got access and manage it directly here in the UI. Now, of course, with sharing comes the audit log and the activity. So just as I shared with him, we make it super easy and simple to view all of the activity of the array. Here we can view the activity at a very high level summary of what's going on. You can see queries that were performed and a link over to the task. The tasks will have the specific details such as the programming language, what ranges were accessed, what attributes, if it was a SQL query, perhaps the SQL statement, if it was a UDF, the text there. We will take a look into tasks a little bit when we go through the computations. Now, I showed sharing with an individual user, but we also make it very easy to share the data publicly or privately. From the settings page, you control all the details of the array itself. I can make the array read-only, for instance. This is very great if it's a public example. You don't want anyone to modify it accidentally, including maybe your own employees or internal users. You can also modify the array, make it private or public. So you simply click this, and you can swap the settings back and forth. Makes it very easy to manage all of this. Of course, we have the categorization, the hashtags, the descriptions, the licensing, all of that going forward. All right, so from all the details here that I've showed you, every single thing works no matter where you are. So I'm going to launch a notebook, and we'll actually do some computations. And then we will actually run the same thing from our laptop just to show you that everything's available in the system. I'm going to launch a geospatial notebook as we'll show you some geospatial dashboards in just a few minutes. Now, once again, when you're in the notebook environment, everything you do here and all the activity gets logged back over in the array activity and the tasks. And we will show the details of that in just a moment. The notebook environments are not the only place, as I mentioned, that you can run the computations. The same notebook that I'm going to show you now is also available for you guys to download, and you can run it from your local laptops. The advantage of the hosted environment is that all the packages are pre-installed. I'm sure many of you that have used Jupyter know one of the most difficult parts is, first off, sharing the notebooks. How do you get them to people? Do you commit it to GitHub? Do you send it in emails? But then the second part is giving people a dedicated environment with the right packages installed. You can use Conda environments, you can use Docker files, but all of these are just additional hurdles that people have to jump over to get into the environment. So in the hosted environment here, we have a large list of packages pre-installed, including all the basic ones for data science, machine learning, the domain-specific ones in geospatial or genomics, such as GDAL and Poodle. This allows you to have one-stop shop for you to collaborate with your coworkers or people on the internet at large without having to worry about the dedicated environments to spin up.